All right, so when you look at things like 4, 5, and 6, those are all numbers. There's no thetas involved. Many of you probably are like, why can't I just add them together? Like, why can't I just do the cosine of 15? Does anybody know off the top of their head what the cosine of 15 is? No, right? That's not exactly something easy to do. So that's why we use formulas like this, because I can make a 15 using some of the formulas I know. Isn't 15 like 45 minus 30? Would give me 15. So I could use a sum or difference formula to get here, whereas I might not have been able to if I didn't know those formulas. So obviously you guys are probably not going to want to find a common denominator for number 4 and see if that's one you know. So let's just go ahead and split it up. What does that look like?
So if we had 2 times cosine pi 6, minus cosine 3 pi 2 minus sine pi 6.
All right, thank you. So again, going back to our formulas, the 3 pi over 2, that is on our cosine sine chart, right? Specifically, it's this piece down here. So my sine is -1, my cosine is 0. Now the pi over 6, what is the reference angle for pi over 6? 30. So I'm working off of my 30, 60, 90 triangle. Cosine of 30 is what? What is the adjacent here?
3 over 1. Oh, 2.
Hypotenuse. Adjacent over hypotenuse. Sine is 1/2. Does it really matter what the sine is? No, because the cosine here is a 0. So if you ever end up with a 0, if you don't want to find that term, you don't have to, because 0 times anything is still going to give you 0. So that part's gone. What's my answer?
So negative root 3 over 2.
Negative root 3 over 2. Are you okay with that? How about the next one? Tangent of pi over 6 plus pi over 4. What does that look like?
All over 1 minus tangent pi over 6 times tangent.
Alright. So obviously the pi over 6, that goes right back into the triangle we were already using, right? What is the tangent of 30 degrees?
1 over the square root of 3.
1 over the square root of 3, which becomes
3 over 3.
root 3 over 3. So the tangent of pi over 6, you can replace with root 3 over 3. Now, pi over 4 is dealing with the 45, 45, 90 triangle. What's the tangent of pi over 4? 1. So, not very pretty, is it? So here's what I would do. I would go ahead and say, I have unwanted denominators, right? What is the unwanted denominator? I want just the denominator. What is the unwanted chunk that's in the top and the bottom that we don't want?
Root 3 over
There's
5.
a 3 that causes a fraction to appear within a fraction. So multiply top and bottom by 3. So the first term is going to become root 3 plus 3. And the bottom should become 3 minus root 3. Now, I'm fine with you leaving it like that, but what's the rule?
The root in the bottom.
The rule is no radicals in the bottom. Okay. So if you chose to go ahead and get rid of that, then you would need to multiply top and bottom by the conjugate pair and then end up with a different fraction. Does anyone want to see how that would work out?
Sure.
So if I chose to do that, 3, which is 9. 3 times root 3 is 3 root 3. Minus 3 root 3, so those cancel. Minus root 3 times root 3 is 3. So my bottom is now 6. On top, root 3 times 3 is 3 root 3. Root 3 times root 3 is 3. Then I have another 3 root 3 and a 9. Okay? So this times this times this, and then this times that, and then this. So on top, I have 6 root 3's, right? And 3 plus 9 is 12. And on the bottom, I have 6. Everything is divisible by 6. So you could go ahead and say 2 plus the square root of 3 is your final answer. That is still way better looking than that is. But I'll take that. Now, we got cosine of 15. Is it going to take addition or subtraction to get to 15? It's going to take
Addition.
subtraction. Which two? Which two of our angles that we know is it going to take? 45 and 30. So I'm going to rewrite this as the cosine of 45 minus 30. Now if you look at your cosine formula, that means cosine of 45, cosine 30. The subtraction becomes a plus. Sine of 45, sine 30. And this is all just based on the formula that we have at the top. So I actually already have these triangles drawn. You guys should have them stored up here somewhere, somehow. So what's the cosine of 45 degrees? Square root of 2 over 2, because you end up with 1 over root 2. You can't leave it like that. So root 2 over 2. What's the cosine of 30? Root 3 over 2. Plus, what's the sine of 45? It's going to give you root 2 over 2 again. And what's the sine of 30? 1 over 2. So, they all have the same denominator, but you need to multiply before you add. Please remember, when multiplying fractions, you actually have to multiply the denominators. So root 3 times root 2 gives you root 6. 2 times 2 is 4. Root 2 times 1 is root 2. And then 2 times 2 is 4. So your final answer is root 6 plus root 2 over 4. If you really, really, really wanted to, you could pull out a root 2, but you don't have to. Are we all right with that?
Here's the question.
Yes.
Here's the rest of it.